awesome, but one of these pretty cool. Brian. All right, afternoon, everybody. So we're here for another E&H Department Faculty Seminar Series. Real quick before I introduce our speakers, just a little bit of housekeeping. So we have one more event left for 2024, and that'll be next month on the 10th. So keep an eye out for an email from Alex to let you know about the speaker, and same time, same place as usual. So with that, we have two speakers today that are going to be talking about different applications for AI in relation to horticulture and some of the things that they've been involved with, and some of their interests and views for moving forward with artificial intelligence related to horticulture. So our first speaker today, I had the pleasure of meeting him a couple of years ago for a project we got a grant for to work on a tree selection website. And his name is Dr. Howard Beck. So he's a professor emeritus from Ag and Bioengineering, and he's been doing a lot of stuff with AI, data management, digital collections, natural language processing systems. He's worked with the Hypergator quite a bit, doing some stuff with EDIS, Fawn, and then he's developing urban horticulture virtual reality systems, which he's going to show you a little bit of that today as well. And his goal is to develop AI and VR for urban development, but then also conducive to environmental stewardship. So with that, I'm going to hand it over to Dr. Beck.
Great, thanks a lot. Thank you for all being here. Okay, first off, thanks to Ryan for inviting me, and I wanted to acknowledge some of the people we've been talking with for a little over 2 years now. There's been a group discussing these issues, and I'm going to present ideas we've had, some experiments we've done, some prototypes we've built, and I think the industry is just starting to catch on to this, and a lot of people are asking about it. So I'm just going to hit a lot of kind of overview topics. Okay, here's some overview of the talk here. I want to talk about some legacy knowledge representation and extension. Knowledge representation is a term from artificial intelligence. You're not hearing a lot about it recently, but it used to be, how do we take what we know and represent it inside of a computer, or put it in some form that the computer can reason about and do some things about it. I've just did an experiment with Ryan on analyzing extension publications and databases. Talk a little bit about site analysis. If you go out and you want to capture what's in your backyard, what's there, how do you do that? Recommendation systems are programs that give you advice on, in this case, what are the best plants put in your yard, and base it on expert recommendations. And lastly, I'm going to try to tie it all together with artificial intelligence VR system that we're putting together. Okay, I do want to bring up pros and cons. So how can these technologies benefit urban landscaping and gardening? First of all, everybody loves plants. If nothing else, we will be creating beautiful gardens, and that's part of the appeal. This is one of the most amazing places I've ever worked in terms of content and things. But there's a bonus advantage. In this age of environmental degradation and destruction, perhaps this technology can be an aid to restoring urban ecosystems, reduce pollution, mitigate climate change. That's good. But we have to be cautious. There are things to talk about. I won't go into all of them, but we know about privacy issues, bias, hallucination. I want to talk about job security. And if you're considering a career in urban horticulture, how will this impact your job? And I think that what's going to happen, at least for the foreseeable future, as these tools are not going to take over their job, they're going to help you with your job. You're going to build personal knowledge management that make you stronger as a professional to organize the things that you do, the things that you know, and make you more powerful. But 20, 30 years from now, it's yes. So anyway, there's a lot of controversies. I'm aware of it and need to be talked about. Next, I want to talk about legacy technologies, publications, extensions. You've all done these. You've all seen them. There are also lots of databases in horticulture, plant databases. And then I'll talk about recommendation systems, a legacy system that we just restored, a rule-based recommender system. Okay, publications. Traditionally, extension knowledge is embedded in publications, web pages, PDF files. It's very much happening right now. People write documents, they write books, they write papers. And that is where the bulk of the knowledge is, at least in the hard form. Okay, we can use AI to extract and more effectively utilize this information in these publications. Conduct fact checking. I'm bothered by the fact that there's so many sources of the same information and they're not quite always agreeing. They can assist an extension specialist in writing the publications. Chatbots are now all over the place. I know of at least 3 commercial companies that have taken the extension publications from IFAS and made chatbots out of them. I think you're all familiar with chat. How many people use chatbots on a regular basis? Okay, I guess get about 50% there. You haven't crossed over yet, but don't worry, you will. They're very impressive, but we also will show some limitations. But in working with this, I'm struck with, I got to ask, how do extension publications, in particular IFAS, how do those contribute to the world knowledge? Because these big chatbots are trained on data from all over the place. And how is an IFAS extension publication different from what may be in some other state? Databases, there's hundreds if not thousands of databases on trees, shrubs, and ground covers. And look kind of like this. They take a plant and they characterize it different ways, and you can check off the boxes and do a search. This is the Florida Friendly Landscaping Plant Guide, same idea. It's arranged by characteristics. The characteristics might look like this. So light requirements, partial sun, or shade tolerant or full sun. It describes the plant. One thing to note about databases, they're very concise descriptions. If you're going to click off attributes, you can't say it very many ways. You can say it a handful of ways. So they're a little constrained that way, but they do make it possible to do searches. Here, so database is basically a table. You've seen, you can use spreadsheets. Each row is a plant, and each column is some attribute of that plant. And these are widely used. And I'm asking, what is the future for these plant databases? They're such an excellent source of knowledge. One question, will they be absorbed into these chatbots, these large language models? And this will just go away. Real possible. It's already happened. This table was generated by Anthropic's Claude. It was just to see. Now, I don't know if I trust it. That's the problem. I don't know where it's getting this information. But you got to see maybe, I think what is more likely in the short term is there's going to be a hybrid AI combined with traditional database systems. So we'll keep our traditional plant databases, but we'll integrate them with AI systems that are capable of searching them. The recommendation systems, experts used to be called expert systems. Well, it's not the only way to do a recommendation system. A recommendation system is something that gives you expert advice. And this is where Ryan and I have been working on restoring a system that was built 20 years ago. During the first wave of artificial intelligence, believe it or not, this hype was around decades ago, and this was one of the things that came out of it. Users answer questions to determine site characteristics, and the tree matches those characteristics to recommended plants. So it ends up searching a database, but it does it with the front end that an expert would ask the questions about your site. In fact, this is what happens if you let Dr. Ed Gilman, who really created this thing, the things that he considers: hardiness zone, sunlight conditions, soil conditions, irrigation, maintenance, but a lot of infrastructure. Over half of the system is devoted to overhead wires may be nearby, lights may be nearby, buildings could be nearby. They are rule-based. It's if then. If you are near a sidewalk, then select a tree with roots that will not damage that sidewalk. And this, I'm not sure, again, if this is kind of an old way of thinking about intelligent systems, is to come up with all these rules. That's what we thought we could do. There's hundreds of them. But I'm reading recent extension publications, and by golly, that's what they do. They say things in very concise sentences that capture, and it really can still work. So anyway, here's what the system looks like. You're answering a series of questions. It's really a conversation. And depending on your answers, it will ask more things. And this goes on for a long time. It can be 24 questions involved. By that time, it's got a very good idea of what your site is like. And then it can search the database based on what it found and what it recommended. So here's the answers. Look under the hood. We point out two things. Yes, the rule. Here's a rule about if you've got sandy soil and drainage is a question. It takes a bunch of rules on that. But notice in the background this graph-like structure. It's a decision tree. It's a chain of logic. One idea leads to another, and that leads to another. And this is a complicated reasoning method that I don't think current large language models are good at this, at least not yet. Don't assume anything. They're good at maybe answering an isolated question, but they can't take a big picture. And I'm going to be wrong about that in another year or two, but that's what we have to have this, and we have to implement it in modern tools somehow. Here's another example. This spans off into almost 1,000 different nodes. But I just wanted to get a takeaway that it is a kind of a rule-based thing, and there's all this connected chains of reasoning that are taking place. Okay, so we have a lot of publications and databases. IFAS website, and I may be missing some. There's EDIS, the Extension Digital Information Source, Florida Friendly Landscaping Program. Florida Trees is the project Ryan and I put together. It's only about trees. There's a UF Gardening Solutions. There's Art Department. I'm going to these websites and they have similar things. Furthermore, there's national and international. UF Herbarium, iDigBio, GBIF, iNatural. So there's a lot of sources out there. One question I would ask is, multiple plant databases provide contradictory information. And somehow we have to be able to merge all this data and information. So Ryan and I have been doing an experiment called information extraction to answer that question. So many disparate data sources, and by disparate I mean they're in different forms. They're hard to work with. Who do you trust? Who do we trust? Hopefully we trust IFAS, right? There's something about it coming from IFAS that has special meaning for Florida. That's for sure. A solution: use chatbots to extract information from IFAS publications and database, and then use tools to evaluate the extracted information. So I'll take information out of the database, I'll take it out of the EDIS publication, and I'll try to see if they agree or disagree. Benefits: fact checking. We can see whether one source disagrees with another, but updating. Maybe the source doesn't agree because it's out of date. And that's exactly what Ryan and I started on. We had the trees database, but it wasn't being maintained. We have new EDIS publications that are just within the last few years updated. We wanted to see, can we update the database from what was in the publication? And short of reading them manually, which is very tedious and complicated, can we use these information extraction techniques to get info out of the publications and then update the data? It's a simple game, but it illustrates the point. We were after plant name, hardiness zone, and invasive species, but this could work on anything in the document. trees, and spread, leaf growth habit. We're just picking these three for the experiment. Turns out these are the three most important things you're gonna want to know about if you're gonna pick a plant. So focusing on that, here's how we did it. Here's our data sources. We have 675 EDIS publications in PDF format. The trees database has 1,300 trees, many which includes northern. And then we started looking at Florida-friendly landscaping, which has a more focused set, 48 trees that we use for our study, out of 133 altogether. I could add more rows to this table. I could have other sources. But we're just trying to see if this works. And the method, we're going to feed each EDIS publication as a PDF file into the GPT-4o, which is one of the latest chat bots from OpenAI. So what you can do is you can give it a document. I don't know if you've tried this, you can try this at home. Give it a document and then you give it a prompt with a question designed to extract the information on that document. What we wanted to know, name, hardiness zone, and invasive potential. Then we compare the extracted information between the two data sources. This is what the prompt looks like. I had to tweak this and get it to, it looks a little complicated, but I kept trying to change it to get the output that I wanted. And eventually it did work. Here's the EDIS pub, and you see for yourself, what's the name, what's the hardiness zone, and what's the invasive potential label, right? That's easy for you, and that's for a computer. Or here's a publication in Florida-friendly landscapes. And here the information's way down on page 42 of a 80-page document. So the chatbot had to find this and get to it, and it's also coded in funny symbols. By golly, it worked. Okay, here's the result. This is what we get out of the chatbot. Here's the information that's been extracted. It's nicely formatted, and I can import this into Python and then do further analysis. Here's the conclusions. First, we did a benchmark where we tested 10 of the publications, and it's almost 100%. There's only 10, so there were 2 that were questionable judgment calls. So I said, okay, we'll make it 90. It's very reliable, and this is consistent with other results we've gotten in terms of accuracy of extracting the information. We'd like to do more than 10. If any of you have some spare time and would like to manually cross-check our publications, we could crowdsource this. Then ultimately we compared the EDIS publications to what was in the tree database. The names disagreed 80% of the time because they had actually changed. That was one of the things we were looking for. Scientific names changed. The hardiness zone was 80% accurate. Some of them changed. Invasive potential changed a lot, largely due to the fact that we didn't know at the time what the invasive. So we did catch what we were looking for. We conclude the database can be updated from information extracted from the publications. And meanwhile, the Florida-friendly results did not agree well on the hardiness zone. I'm not judging which one's right or what. It says we proved we were able to detect differences between publications on different sources of the same plant, and that's what we were after. And then we can go further and try to fix it. Okay, back to recommendation systems for a while. How do we build recommendation systems for urban landscape? In the age of deep learning, we gather huge collections of landscape photos. Here's what it looked like, and try to learn from that. We have to move on. What can we use the same technique that we just showed to extract rules from design publications? We got a lot of them. Here's one: utility box problem. And here's an excellent publication on using natural environments to inform design of your lands. It's a really excellent recent publication. Can we extract design rules from these? Okay, here's a page from that document. You'll see this all the time. A nice drawing, all this advice, plants to attract wildlife, capture stormwater. We fed this diagram into Google Gemini, and we wanted to see, can it extract these rules? And by golly, look what happened. Here's the overall design, a variety of colors, textures, and types are used for visual interest. Plants with similar water needs are grouped. These are the rules. It did it. So there's hope. Then I thought, wait a minute, this is too good to be true. So I thought, does it really understand this diagram? So let's make it, I told it to make a new version of the diagram with a slight modification, expecting to get it back. Well, nice try. Let's kind of make a new diagram with lots of different dimensions. I think it kind of got the trees around the perimeter. I mean, it's way off, obviously. We have a little work to do, and I'm not saying this can't be improved. Certainly it can. We have to refer to a quick note to a magazine called Forum for the Humanities to take this idea of design to another level. They've been talking about sense of place. What is it about your house and your neighborhood that you love and that is characteristic of how you live there? Can we extract that sense somehow and pull it into the system? Yeah, and here's architectural. We got to get with landscape architects. Is there part of the landscape? I have to point out the buckling in the sidewalks. They should have used our recommendation system. They would have avoided. But to think about even higher, social economic, no matter whether you're rich or poor, design your landscape. Moving on time a little bit. I have one slide on site analysis. The idea is you take your phone out to your yard, you take a picture, and you get a list of recommended plants. Good luck with that. It's our dream. It's our dream to do that. I think it's not at all easy to do. You want to know a lot about distance between objects, reconstruct the home. Will there be drone companies that come to your house and fly around and recreate your house landscape? Can we infer soil characteristics, moisture, drainage, and nutrition? I think we're going to have to do more than take a single picture to do that. But this is there's a lot of work to be done here to figure out how to do that. Okay, lastly, the database virtual reality, immersive visualizations of urban landscapes in 3D. Why do we want this? Well, one is a use case well, the obvious one is I wanted to do something in my yard. I want to know what it's going to look like ahead of time. That's what everybody talks about, but I think there's an even higher calling in the sense that this is going to be the new horticulture and landscape textbook. It's going to have everything we know about the landscape. There's certainly educational offshoots of that. That is a long-term thing. Okay, I always enjoy reading these things. Virtual reality nature cannot provide the same wellness benefits as the real thing. Well, I would never argue with that, but I would counter argue, yeah, there's a lot of advantage to doing this. I can't always get to the forest. I want to see the forest. The VR system knows all about things in the forest. It's fun to just read these, and I mean, people are concerned, and rightfully so, but good to talk about. Okay, now, so we're developing an AI and extended reality platform under development here. There's an AI database backend with all botanical and horticultural information. Human-computer interaction via virtual reality and others. But I don't have time for this slide. To build such a system, we have to have really quality plant models, and we're doing a lot of work. A lot of them are drawn by artists, but we need more flexibility. So there's a lot of work to be done in. These are mathematical models. I can't show that slide didn't come across. Okay, this animates opening up. We're learning mathematical structures of plants, and we're using machine learning to parameterize the plant models. So here's just some things in this platform. We just added an AI assistant that's capable of searching databases and finding plants that find all the palm trees, find all the trees that grow in the hammock woods in north central Florida. It's coming back with it. We have a database of plant models, and that feeds it to the interface, which, by the way, is not just VR. It could be augmented reality. It could be a web browser. It could be web pages. It could write. It's going to write extension publications if you prefer that format. You can have it. Here's kind of what it looks like. It's flooded in sunlight and color. You feel this is not do it justice. If you're in the VR headset, you're moving around in here and you're immersed in that environment. I think that works well. I think a criticism is it still looks a little cartoonish, but don't worry. That's because the models. The models aren't quite those little squares that shouldn't be there. Don't worry about that. Or we have a tool that you can make the landscape. You're in there and I want to put a tree here, it pops up, and when you pick a tree, you put it there and size it. But even better is called procedural landscape generation, which give me an area and take these trees and put it in this area. And we're doing it with the actual environments now because it's easy. We don't have to worry about buildings and infrastructure. That's the kind of logic we need. We combine that with the AI assistant that does recommendations and then physically puts it into the environment. We now have the pieces to bring this all together. So it's easy to make a pine flatwood for us. Here's just a few more pictures. If you're on the edge of a pine flatwood, you want to make your house compatible with that. If you're a bee, you can do a bee's eye view and zoom right into those flowers. Or maybe it's an arboretum. Here's some maple trees. These were all created in this platform. And I do believe we now have critical pieces. We're just at the very early stage, but combining expert knowledge with algorithms for plant layout and the VR human computer interface, that's where we're going. I don't think I've covered every possible thing here. I think we're going to wait till the end for questions. So let's see if we can get Lance. He's here.
That sounds great. Should I take over, Howard? Can you guys hear me?
I hear them.
Okay.
You
Is
guys
that-
hear?
Okay, I'll keep talking until we get
There he
to.
is.
Thank you, Dr. Beck.
Thanks, Dr. Beck. Okay, so Ryan, I guess we'll try to. I just want to confirm you can hear me in the room as well.
Yes, he's muted the audio. Oh, select the speaker and.
Okay, so they're taking care of that.
There he is.
And then I guess I'm going to request a share. So we'll get through this. So yeah, I'm happy to say
Wow.
you can hear me. Great. Hey everyone. And then I sent a request to share. Great, I can see my sharing screen. So we'll be there in just a moment. Okay, so wonderful. Perfect. I'm just gonna go ahead and do one more thing here. Just practicing my my Zoom sharing etiquette. Okay.
Change the audio.
Yeah, click on the audio.
I'll go ahead and take my time until you guys in the room can confirm we're okay.
Would you mind speaking, Lance?
Yeah, can you hear me okay?
We can hear you, it's just faint. Very faint.
Do you want me to talk louder? Does that help?
We're changing the speaker settings, trying to get it.
Okay, yeah, take your time. I actually said to myself, I'm going to try to tighten up my presentation so we can have time to have questions and talk and get the kind of burning questions you guys have across.
All right, well, we can hear you loud and clear now. I'm going to introduce you if you're ready to go.
Wonderful. Yeah, you want to make the introduction?
Yeah. So similar to Dr. Beck, I met Lance kind of going down the same project rabbit hole, and it was a couple years later, but I've known him for about a year now. And Lance is a former Gator, and he's the founder and CEO of 3CO. He had a physics degree here from 2010 when he was at UF. And then his company, 3CO, got startup funding from the Royal Flora, Holland, Techstar, and Google when they started out. And he develops AI and then 3D plant models for iPhone Pro camera, and he's done some stuff with LiDAR data. And then his new AI platform, Ecodash, has about 90,000 native species in it. And it's basically a geographic recommendation system. Make sure, you kind of plant different trees that are good for that location. And it's got 100 different parameters that you can include in to make sure that, you're identifying species that are good for that site. So with that, I'm going to hand it over to Lance.
Awesome. Thank you, Ryan. I just want to say it's been great collaborating with Ryan as well as Howard. and a variety of folks at UF who I'll mention. But yeah, definitely really happy to be presenting to you guys. I just want to encourage you guys to understand that, you know, a lot of this is work in progress, and we're really looking for collaborators who are expert in the various dimensions. So sort of opening your mind to thinking about a collaboration right away. So this is just a beautiful, so we're going to talk about ecological intelligence, and our particular focus is going to be on understanding the environments that we're in, particularly for the task of designing plantings that are sustainable and have many ecological benefits. And so this is one of them by Pitu Dolph. This will be the only AI diagram I show you today. This is from my master's thesis over 10 years ago. And I just wanted to say that basically, I'm extremely fortunate because my professor who advised this thesis, he was directly advised by this year's Nobel Prize winner in physics. And so it just turns out that there's a variety of these neural networks that you can use to encode information. And that information could actually it could be scientific models, it could be scientific data. So we're talking, you know, physics, chemistry, biology, ecology, geospatially distributed. We're increasingly seeing neural networks learning to encode all of these scientific models, as well as the data sets that, you know, would allow us to give accurate recommendations, as Howard was kind of getting into the trustworthiness of existing models. And we're seeing that they can not only learn to encode these things, but then solve various tasks. Once these sort of foundation models are trained on massive data sets, they typically can solve tasks far more effectively than, you know, sort of previous models, basically. So it's really nice to mention as well, we're currently developing these models. We're developing a foundation model for ecology. I'm right now in the Redwoods next to Stanford University, and I'll mention a collaborator who we're working with. And so I think there's just a lot of exciting things going on. I'm really excited to be talking with you from the Redwoods. So I wanted to make sure I give credit right away to basically some of the key folks behind our work. I think I also wanted to say right away that, you know, I haven't been focusing on ecology for more than maybe a year and a half. You know, I've been looking at 3D modeling of plant species and understanding challenges in 3D reconstruction, which it turns out are really useful to just kind of have this 3D spatial framework when you're looking at understanding ecosystems. I've been doing that for over 8 years, but what I would say is that it's because of folks like you who actually understand the domains that we are interacting with that we can successfully learn to, you know, bring AI to encode that and then build tools for everyone that's just far more effective. So I'm really giving credit to all of the scientists here. We're also working with a lot of industry folks. And so the Florida Association of Native Nurseries, we've now partnered with over 175 nurseries. Howard was giving credit to Chris Haidt at this really, you know, state-leading landscape architecture firm. Just last week, we were doing a workshop there for designing our platform for doing planting design AI systems. So there's just a lot of folks who, you know, we want to make sure we understand this is a large consortium of folks who are coming together, including from Stanford, as I mentioned. So okay, so just to step back, the whole idea, it's very similar to what Howard described. I think it's going to be actually a lot of parameters that Howard was getting into about going to a site, maybe with your phone. But increasingly, I do think you're going to not be able to capture, you know, the information you need for a site survey that's equivalent in quality or better in quality to what a landscape architect would do with just a single picture. So I think, you know, there's challenges of like soil pH, distributed across the site, drainage, topography, these kinds of things. It turns out we're going to mostly be looking to infer through things like drones, but also through things like understanding the existing ecosystems and making inferences of the underlying properties of the environment and the microclimates. So these are challenges that we're currently focusing on. But ultimately, it's all about having AI just help you to understand your environment and then recommend, you know, right plant for right place, as Ryan Klein would say. So I just wanted to kind of say, like, hey, look, you know, the big problem is actually not that we haven't figured out how to design these plantings, because if you're looking at this guy here, is dashing Pitu Dolph in his gorgeous Dutch garden. You know, this is probably the world's best designer of ecological plantings. He designed the Highline Gardens in New York City, which have created several $1 billion of value for the people in the city who own the real estate nearby and for all the tourists. Now the #1 tourist attraction in the city. And I'll talk more about the economic value of the work that we're doing. But I think basically the big problem is that it takes an obsessive decades of work to understand each of the plant species, to understand their growth patterns aesthetically, but also the phenology of when they flower, and so there's just a variety of factors that most of us who would design a garden don't have the time to do. We don't have the ability to study all of the species. We don't have the interest in being this obsessive. But I think what's fantastic is knowing that the sort of formula for creating these gardens has been established, and AI could potentially help us to automate and scale and optimize how we work with that. But the big problem is, again, that there's just not a lot of these people out there. So, the real solution that we're looking at is, can we get an AI system that can automatically go ahead and put together, the right plants, right place, but you might go beyond just the question of, a sort of microclimate and ecological sustainability from the perspective of just survival. And you can start to introduce additional factors into this optimization, including, aesthetic interests, but also, for example, does it deliver other functional benefits? I think ultimately what we're going to get is this, this AI systems that will be kind of, neural networks that will be trying to tune these different objectives, because that's what they do really well, and ultimately try to solve several problems at the same time at the stage of planting design. And so, it's just kind of amazing that planting design is all about selecting the plant species and then placing the plant species. So, we really want to carefully understand how previous designers have, placed these plants to achieve the gardens that they've achieved, which is one of these diagrams that we're looking at here for the New York Botanical Garden, also by Piet Dolph. But we're just so humble. I mean, it's taken a long time to even start to piece together what goes into creating a diagram like this. So what I'm going to do now is switch gears a little bit and just kind of talk about some of the data sets and some of the models that we're currently developing upon, and really trying to kind of open your mind to the different things that we're looking to bring together into what I described as a foundation model for ecology. And so for Howard and for Ryan, some of this is going to be new, actually. But basically, it's sort of what's exciting me today is this idea that, the Nobel Prize winner in chemistry for 2024 also built a sort of neural network for biochemistry, and it's called AlphaFold, and it has over 16,000 publications in Nature. And it's just completely revolutionized. It can now predict proteins it can predict 200,000 different protein structures with unprecedented accuracy. And I'm saying all of this because I think the same exact approach to sort of learning a variety of physical data sets with a neural network can apply to our field. And so that's why I'm going to just kind of talk about the data that we can actually machine learn on. So this is just a beautiful picture of a pitcher plant. It comes from iNaturalist, and I'm just going to loop through a few photos here for a second. These are just some of the, I think it's close to like 400 million photos from iNaturalist that have been collected over the past like 5 or 6 years. So these photos have GPS coordinates. They've been classified by, various citizen scientists, the exact time that they were taken, the photo, all of these things becomes really valuable when you're thinking about potentially having a machine learning model look at all of these photos and understand the locations where these photos were taken, understand the fact that if a species was photographed at a precise GPS location, it tells us also about the habitability parameters that species is very likely to require, given our knowledge of other data sets of that location. So this is just a beautiful night orchid, which I like a lot. But basically, to speak of those other data sets, you start to overlay the biodiversity data sets with these other kind of, bioclimactic or, other sort of physical topographic types of data sets. In this case, this is an elevation visualization. But what we're seeing specifically is that basically it's color coded such that the darkest blue is actually like closest to sea level. And so we're looking at Florida, and it's just kind of beautiful how the elevation just naturally gives us this like structure of the rivers. And so when I was starting to dig in with the landscape architects, they were like, look, the hydrology and all of the moisture parameters and everything is largely driven by elevation. And so, and then that largely drives what the ecologies are. So, you know, certain parameters like this, which USGS has collected at a 10 by 10 meter resolution, which is very high resolution, which is why I gave you this cutout here of the red, focusing on a nature preserve in Orlando, that I was personally visiting with Christina Haidt, and I was walking on the boundary of one of these, you know, very dark to kind of lighter blue literal changes in elevation. And she didn't know this. She didn't have this elevation map, but she knew it looking at the ecology that there was an elevation change. And so basically just the experience that these landscape architects have who spend decades acquiring this kind of understanding of the field, that's something that we can embed into a neural network, is my point. So that's obviously exciting. The next thing that I think is really fascinating, I just wanted to mention it because we sort of have a variety of these parallel research threads that, in addition to creating a big foundation model, we're really interested in solving certain things very effectively. One of them is inference of soil pH. We understand that this is a big problem in the industry right now where, you know, most gardeners, by the way, most like retail gardeners would never even bother to go ahead and put their hand in the soil and send it to a lab. It's just not going to happen for a lot of people. I don't know, maybe that, whatever. So my point though is that if you can get a system that starts to infer that both from remote sensing, which this map was based upon at a basically 250 by 250 meter scale, which is still not high enough. But it is interesting because what this cutout shows is that on this beach in basically Apalachicola Bay, basically you can see the brighter green showing a more basic pH because, you know, you have a lot of these beaches with sort of more basic pH levels. And so you do actually have some of these remote sensing maps. This is a global map, by the way, that can give us a lot of basic, like, kind of estimates of where things are at. I just think that when I started to present all this stuff with, again, with the landscape architects going back and forth to get this AI tool working with the people who do this every day, they were like, look, that's great, but it doesn't replace the site survey. So I just want to point out that you know, there's a lot of, the resolution of this data is not high enough, is my point. It needs to get to the point where you have like 1 by 1 meter soil pH estimates, which you might not be able to get with satellites. I mean, you probably can't. So that's that. Again, I mentioned I'm going to kind of throw out a variety of these research threads. And if you're interested in any of them, you know, I would love it if there was like a follow-up, and I'd love to meet one-on-one with a lot of folks here. But basically, there's this work in land classification. We have not done this. This is funded by like Florida Department of Environmental Protection and other agencies. And all I wanted to point out here was that, you know, a lot of folks have thought about basically going from the ground up. How do you even begin to name an ecology? And, you know, I know there's probably folks listening now who maybe focus more on this kind of perspective. I think this is extremely interesting. And I just want to say that we currently have someone working on this. That's like her only project is she's actually going onto the field right now, collecting data on plant species. And we're looking to be able to name ecologies. I just want to mention this because, again, it's a side research project, that there could be something like Howard talked about with this GPT retrieval augmented generation system, that basically you can imagine feeding it species and different parameters of shading, moisture, something like this. And then it just names it, you know, sandhill, you know, shrubland or whatever, right? And so anyways, I think this is very interesting because if you can do this in a dynamic way at a very high resolution anywhere in the world, I think planting designers would be greatly assisted in what they're trying to solve. So I do want to spend a second on this model. This is why I'm at Stanford right now. And basically, this is really exciting. So this is basically what we're looking at is a visualization of a global native plant distribution model that has 200,000 plant species. I still need to talk with the professor to see if that makes any sense at all, because it might be some of these like varieties and cultivars and stuff, but it's somewhere between like 100,000 and 200,000. And it's basically most of the world's, or all of the world's plant species, I want to say. And what he's done is he's gotten it to a 9 by 9 kilometer resolution. So we could zoom into Florida and you could actually see, you know, we would start to see like the Gainesville area, for example, would have its own kind of native plant ecology that's captured in his model. And basically he's done both native habitat modeling as well as sort of suitability or habitability, you know, getting into invasive perspectives as well. And what I've done to sort of audit his model, because I wasn't really sure if it was any good, but I don't just believe a publication. Basically, I decided to overlay it's like, maybe I can zoom in. Yeah. So I decided to overlay these cross hatches, which is the native habitat range, basically, with these dots, which are, which are basically the real observations of from captured from the Global Biodiversity Information Facility, GBIF. So this is showing that his habitat model effectively is kind of, fitting with the observations. Some observations are strange, as you can see here, but basically it's overall really good. You can study it. And I'm really delighted to say that I expect that we're going to have all of this online for everyone, for free at Ecodash, basically. So I'll talk about that briefly. So that's all I'm going to talk here. Basically, I just wanted to mention that. So we're going to switch gears again. So that's native habitat models. There's this other challenge that, when you're designing a garden, you face. Howard talked quite a bit about databases and the value that databases give you for search, and versus like an LLM, which you're sort of left with uncertainty about its reliability and so forth. And it's absolutely a big problem and a big opportunity. So I would just say we're well aware of like FFL's databases. We're well aware of IFAS's databases. We've seen all kinds of databases on the web. And eventually I was just like, you know what, we need to make a new one, because we need to leverage the GPT systems which are, these chatbot systems, to do exactly what Howard said, which is instead of just asking the system sort of like what it thinks, which we don't care because we can't rely on it, we want to feed it authorized, sort of basically authenticated data from trusted sources, and then have it interpret that data in a way that has a structured output for a database. And that's what you call retrieval augmented generation. That is RAG. And it is revolutionizing the field. It is considered state-of-the-art in AI. It is basically the safe way and the smart way to do AI. I have to give credit to Howard for even tipping me on this, because he was the one who was like, I think RAG is going to be it. And I was like, okay, Howard, okay. So just saying that because Howard deserves a ton of credit for leadership all around. Basically, this system here is really a system that has been designed. It is online today. I thought I might go into a little scientific perspective on it for a second, and just point out that we've looked at, as Ryan mentioned, a very large number of parameters. It's actually 66 parameters, but then there's like 300, over 300 possibilities for those parameters. So the actual parameterization, if you will, in some species, for example, for their sunlight preferences, I've learned that I guess they might change geographically, but basically you might think that some species might, prefer they're tolerable for full sun and partial sun, something like this. It's important to say that, obviously I would love it if like these parameterizations were in like values of physics, but it just turns out with the chatbot, this was the most reliable way to ultimately have it make these inferences, and it also corresponded with the existing data and literature. And so what I'm going to do here is briefly just kind of give you a peek at some of how this system was built, because again, this is online, it is accessible today. And basically what you're looking at is something that we basically fed it the evidence for, in this case, an oak tree. And you sort of give it this evidence. In this case, it's been carefully filtered automatically. It actually is from 800,000 web pages, including lots of IFAS, lots of folks, including probably you. I think what I want to do as soon as possible, as soon as we have some money, because by the way, this is all coming out of pocket and some small, investors on the side. Basically, I want to be able to give full credit to everyone who's contributed the original publications to this work. There's a good platform called Perplexity.ai, which when you research something from the chatbot, it will actually link to the sources, basically. And so that's really important to say that that's where this is going to go. But right now, basically, the system is online. So it's important to say that someone says we ship code. And what you're looking at here is just I'm not going to spend much time on this because I have a 3-minute timer on my clock right now. But basically, what you're looking at here is just the demo. It basically shows you beautiful pictures. We did try to get a machine learning algorithm to select pictures for their beauty, but that can be improved. And you can search anywhere in the world. So it's important to say that the actual native habitat models are not great, but I'm just going to say that. But basically, they are going to be improved by the ones that I'm currently interacting with here at Stanford. And basically all of those parameters that I described are accessible through, you can open up and close the menu basically. So just to kind of give you, if I can change the screen. Yep. This is an example of clicking on the button for an herbal, an herbaceous plant. Maybe you want something that takes in shading, that requires shading or prefers shading, and maybe the soil is moist. And by the way, every plant here is native, so or is supposed to be native. So basically, you select these filters, and then instantly, you get this new visual of the plants. Right now, there's some retail links. We're actually not really super focused on that right today. We're really more focused on connecting with the commercial wholesale nurseries to make this a professional tool. But basically, right now, if you click on these pictures, you'll be led to the GBIF links for each picture. So I'm just going to show you a few more demos real quick. Full sun, alkaline soil, mitigation of floods. Think about all the environmental things. We started to have the systems infer that. And I just kind of want to encourage folks to take their own views on this system. This is a system in development. And so, you might think of things that you want the system to infer or to have instantly filtered. Does it support green stormwater, retention, something like this? And so I think it's really interesting to basically just kind of imagine how AI is going to help us to not only automatically search these things, but ultimately these inferences will be used to automatically generate designs as well. So we don't have a lot of time, so I'm not going to focus on this, but I will tell you there is a plan here to build this AI system in a reliable way for automatic generation of planting designs. The thing I did want to spend a second on is to just talk about that this came out of the ASLA just yesterday, and it was just really cool to see that they're really tuning into the recognition that, if you can make these economic arguments to, let's say, real estate developers or cities, that by investing in parks and nature, you're going to increase your economy. In this case, they've proven from 175 case studies, a single dollar invested in parks and green spaces brings $4 to $11 or 4 to 11x or 5 to 10x, maybe to give you some round number. So basically, that's big, right? And we've been looking for that in the industry because I think it's what people need. It's what people need to basically drive all of this, is just to know that, hey, this isn't just a feel-good story. Turns out environmentalism and supporting the environment is good for the economy too, which is pretty crazy. So anyways, so that's it. That's all. And I'm happy to open up for questions right now. So yeah, I figure probably nobody's got burning questions, but we can start to shift that. Yeah, Ryan, if you want to go for it.
All right, thank you, Lance. So I'll try to repeat the questions so everybody can hear them, but any questions for Lance or Dr. Beck? Aaron.
Yeah, this is awesome. Thank you so much for sharing all these updates. I guess my question is, are y'all bringing in practitioners who are actually installing and managing the landscapes in addition to designers and architects in this process? Because it's a known fact in the field that LA's design things, and then when you get to the site to install them, the design may look completely different than what was on paper because of the site facilities and what's there and what can't be seen in the site analysis. And I guess I know there's not like a major database for management, but both from looking ahead and also I can see how this would be really useful for landscape maintenance professionals because it's much more formulaic than design. So I guess my question is, where is that? I know it's all early days, but have y'all looked at that and tossed it aside? Is that part of the plan?
Is this a training?
Yeah.
How do you train the practitioners?
No, how do you train the AI to get the data that practitioners have that isn't quantified online in a database? Like to his point about Hugh having this ecological knowledge of the plants because he's been a practitioner for so long. I might get a landscape design from an architect in Michigan who saw the site and has a list of plants that work for Florida, which is effectively like, a simplified version of AI. And then I get to the site and see like, oh, well, this isn't available here. This won't grow here. This is too tall. We have to move because there's, like to his point about being on site and seeing the plants are indicative of the hydrology shift, a site designer would be on site to see that. So like the on-site adjustments that occur outside of that.
Yeah, I'll just quickly respond and say 100% that's where we're going. Because I think, we just recognize that maintenance is where most of the landscaping actually occurs. And so, yeah, let's say that's in the earliest stages of this whole thing, which is why it wasn't discussed. And we have a question from Swati. Oh, you're muted, yeah.
Hey, Lance, wonderful presentation. Hearty congratulations on the idea. It's amazing. I just browsed through your Ecodash. Wonderful, thank you. So in your neural networks, what kind of input is going? You showed geospatial data, elevation. Right. Are you taking all these, like looking at the website, it seems like you're getting observations from various herbaria and everything. So do you plan to increase what's going as an input into your neural
Yeah, that's a
networks?
brilliant question because it's actually at top of my mind today as I'm meeting with folks. And I think it's a brilliant question because, first of all, I just want to say you all know what the input should be together. So it's important to put it this way because I probably have some perception on like, oh, we need to collect this data set, this data set. It's a variety of hypotheses, but the experts should ultimately define this. I think there's probably a Nature publication here where there's 20 or 30 of us on it, honestly. So that's nice that I can offer that. But I think what the answer to your question specifically is, there is actually some things we know are going to go into it. We know actually we're going to put genetics into it. We know that we're going to put the plant traits are going to go into it. They're probably going to go into it as something like a matrix where it's the species and the plant traits basically. And I think, by the way, the current system is only about 33% fleshed out. So the neural network is going to help us to predict the rest of the plant traits. And then last but not least, the thing that we know is going to go into it, in addition to everything else, is those biodiversity occurrences. We know that that data set is just so rich that, if you sort of combine the genetics, biodiversity occurrences, and plant traits, and then it's important to say there's the whole Earth systems factor, but those are the three things that I really focus on. So.
And one other question, in your website, like Ecodash, what is the kind of information that we can get on a particular, like I look at, are you also taking in the fawn data, for example, in Florida, where this environmental data that's existing at multiple locations?
It's a great question. I think I would think of the current website, and I wanted to make sure this was clear as well. It's just the first thing that I wanted to actually get out the door. So, but basically we're literally developing an entirely new version of it that's connected with Google Earth, and we've already got some early stage demos of it. And so, anyways, I just want to encourage, this is an ongoing collaboration. So please reach out if you're having any, these are great ideas. So, yeah.
Awesome. Thank you. Put in your email in the chat.
Oh,
Thanks.
okay. I'll do that right now. Okay. Thanks.
Do you have anything to follow up with, Howard?
Oh, I did want to make a comment about data sources for training. Since I've done more work with this expert knowledge, we've got biodiversity databases, we have climate databases, we have all that kind of data, but working with experts, which originally was by interviewing experts. And I'm kind of going down the track. What can we extract from the publications the experts have written? How can we get the experts engaged and interacting with the system to leverage their knowledge? That would be a very valuable source. That's something we're pursuing.
All right, awesome. We got one question in the chat here from Vincent. Are invasive species changing how you define ecoregions? Could that be used as a tool for redesigning, reconverting areas back to native landscapes?
Yeah. I just want to say right away, the answer is yes and yes. At some point, I think, Ryan, folks who we talked with were like, hey, invasive species are a big problem. We actually had a proposal, I think, Ryan, that didn't quite make it right. But basically, I'll just say the current Ecodash removes invasives. So it's important to say that. And then, we see this as an environmental restoration tool. That's at least one really important application of it. And maybe for this audience, that's the most important application, you could say.
So Carrie?
I was just gonna remark on that too. I'm on a review paper with some people, we're talking about trait-based restoration, where you're selecting species for revegetation projects that are not necessarily historical dominance for any one location, but rather you're selecting the plants based on the traits and the potential ecosystem services provided by the plants.
Exactly.
So I hear the traits as part of the next step for Ecodash. That's really cool.
That's 100%. Like what she said, that's the future for sure. It's basically you're still planting native, you're still doing it appropriate for the microclimate, but folks want to additionally add this to become a pollinator garden for visual aesthetics. Folks might want to make this a coastal resilience planting, for climate, rising oceans and et cetera. And so I think it's going to be this combination that she's describing. That's 100% where this is going. I'll just say again, I think this is so exciting, and you guys being the experts, please reach out because I think there's going to be a lot of collaboration, I think, coming from this. So
any more questions here or online?
a shameless plug, we're contemplating a workshop. We did one a year ago. And we're hoping by this seminar to get groups of people talking, and if there's interest in participating in a workshop, we're gonna talk about it. Please send us some feedback if you would like to present or participate in the workshop on AI and urban work. It'll be held here.
Yeah, and we had it at PSF last December. I think we had maybe 25, 30 people in person, just many online, but when we kind of start the planning of it, I can send out an email to kind of just gauge interest. If we need to get a bigger room, we definitely can.
Did y'all include the trade associations like FNGLA and ISA, or is it just for?
It was very localized last year, but we're open to.
It'd probably be really good.
So, all right,
Yeah, we're
well, with-
starting to get we did an FNGLA presentation, Howard and I actually. So they're really receptive to us, and then FAN has been a big one for us as well, basically, that we're now connecting with. So, but yeah, we could probably integrate them if it makes sense.
Well, thank you very much, Dr. Beck, Lance. Appreciate it. Great insight, and I'm sure you're going to get a lot of people blowing up your email.
Well, it sounds great. Well, thank you to everyone. So yeah, have a great, wonderful afternoon thinking about AI and plants and the future of nature. So thanks to everyone. All right. See you guys.
Thanks, Ryan. Are you good, Tom?